Hello everyone. In this video, we will be discussing some of the topics from the V-build drive. That is the selection, starting from the selection of the V-build drive, the length and the cross section from the manufacturing catalog point of view, and the construction and applications of V-builds we'll be discussing in this video. So before moving to that, when we see about the selection of the V-builds, even we can call it as a type of V-builds. So according to the Bureau of Indian Standards, so BIS 24941974. The V belts are basically classified as A, B, C, D, and E type based on the cross section of the V belts. So V belt we have the many categories. So all these categories it is finally divided into five types, that is A, B, C, D, and E. And moving to the specification of the V belt, the V belts are designated by its type and nominal inside length. For example, a C2845 belt has a cross section of type C and has a nominal inside length of 2845 mm. So this is how the belt name has been specified. And moving to the next one, advantages of the V belt drive over the flat belt drive. So this is again a very important concept, because in examination point of view this question is important. So the first point would be the power transmitted is more due to the wedging action in the grooved pulley. Because in case of the flat belt, these kind of wedging action is not possible because it is very flat and thickness is uniform. But since it is having a wedge shape, so the power transmission here is more. And second point, the V belt is more compact, quiet, and shock absorbing. And the next point is the drive is positive because the slip is negligible due to wedge action. And the next point is higher velocity ratio up to 10. So here the velocity ratio is very important, particularly when we solve or when we design belts. So here the velocity ratio value is considerably very good, and the V belt drives can operate in any position, that is horizontal, vertical, inclined, any position it is possible. And we have multiple V belts where we can use that, and that enables the more power transmission. And it has some disadvantages also. So what is the disadvantages means, it cannot be used with large center distances, and it is not durable because the bending stress is more, and the V weld is subject to certain amount of creep. So therefore it is not suitable for constant speed application and timing devices, and even it cannot be used for larger power, and the V belt efficiency is lesser than the flat belt efficiency. The construction of the V grooved pulleys is complicated and costlier compared with the flat belt pulley. Okay, it is little expensive. And moving to the other things, like from the manufacturing catalog point of view, like we have to discuss something about V flat drive, then only we can able to remember the applications too. So in a V belt drive, if the large grooved pulley is replaced by a flat faced pulley and a smaller pulley remains V grooved, so then that particular drive we are calling it as a V flat drive. So these V flat drives are used in domestic piston pumps, domestic clothes dryer, and larger punch. These are the applications. So they have mentioned this as a separate top, like a name in the syllabus, but actually the applications are limited only to these things. That is domestic piston pumps, domestic clothes dryer, and larger punches. And moving to the next one, the next part of the syllabus, that is the wire ropes. And the wire ropes are used whenever the large power is to be transmitted over a long distance, that is up to 150 meters, where these wire ropes are recommended. And these wire ropes are extensively used in elevators, oil well drilling, mine hoists, cranes, conveyors, suspension bridges, and other material handling equipments. And what are the advantages of wire rope, if you see, means it is usually very light compared to the chains or like a belts. It is very light, and the high strength to the weight ratio, that is also one more advantage. And it is more reliable in operation and silent operation even at high working speeds, because if we talk about the chains, it is very noisy, and even the belts also, like some kind of noise levels will be there. But here the operation is silent. Operation is very silent, and even at high working speeds too, and there is a less danger for damage due to the jerks. So what are the materials we can recommend for the wire ropes means, we can recommend wrought iron, cast steel, flow steel, and alloy steel. And how can we classify wire ropes? So the first type is cross lay ropes. So in this rope, the strands are twisted into a rope in the opposite direction to that of the wires in the strands. And second type is the parallel lay ropes. So in this rope, The direction of the twist of the wires in the strand is the same as that of the strands in the rope. And the composite laid ropes. So in this ropes, the wires in two adjacent strands are twisted in the opposite direction. So when we discuss the wire rope, we have some specification. For example, if they mentioned a 6 cross 7 rope means a rope made from 6 strands with 7 wires in each strand. And we shall discuss even the design procedure for a wire rope also. The first one is we need to select a suitable wire rope, that is suitable wire rope for the given application, whether it is 6 cross 7 or 6 cross 19 or 6 cross 36 or 37, whatever thing. So standard designation is mentioned here. Based on the application, we can select that. So if it is 6 cross 7 ropes means it is application is for the haulage and the guy rope in mines, tramways and the power transmission, and the metallic area of the rope usually is 0.38 d square. And if it is 6 cross 19 rope means it is usually mainly used in hoisting ropes in mines, quarries, cranes, derricks, dredges, elevators, tramways, well drillings, and the metallic rope area usually is 0.40 d square. And for the 6 cross 37 ropes, it is application will be extra flexible hoisting rope in steel mill ladders, cranes, high speed elevators, etc. And the metallic area rope would be 0.40 d square. And for 8 cross 19 ropes, the application would be like extra flexible hoisting rope, and the metallic area of ropes is supposed to be 0.40 d square. So I think with this we can wind up this particular thing. Even though the chains are not a part of syllabus, but it's better to know what is chains. So chains, it is comparatively like very noisy, and even the friction also will be more. So just quickly I'll discuss of what is chain drive. So chain drive is intermediate between the belt and the gear drives, and the chain drives are used for velocity ratios less than 10 meter per second, power ratings up to 125 kilowatts. And the applications, if you see for the chain drives means transportation industries such as bicycles, motorcycles, and automobile vehicles, and even when agricultural machineries, metal and woodworking machines, textile machineries, building constructions, material handling machinery. So all these are the applications. We can able to see one example of a chain drive. We can able to see one of the example for the chain drive, and this is how a chain drive looks like. Almost like a two like a smaller pulley, a larger pulley, what we discussed. Here also same thing, but instead of the pulleys, here we'll be going with a sprocket, or we will be calling it as a pinion. So pinion and the gears are the like the things we will be calling. Usually the smaller one will be the pinion and the bigger one will be the gear. And here you can able to see like a lot of chains is connected together, and the chain you can able to see this part we will be calling as chain link, and this part will be calling it as a hinge. In bicycles, I think, and two wheelers and all, very commonly we could able to see this. Advantages means they can be used for long as well as short center distance, more compact than belt, no slip between chain and sprocket, and they provide positive drive. So one chain can be arranged to drive several sprocket, higher efficiency, and transmit more power than belt drives, and smaller loads on the shafts than in belt drives. Disadvantages would be precise alignment of shafts than the belt drives, and it requires more maintenance because metals no, so easily it will go under friction, and it is a very noisy operation. Already we discussed in the previous segment, and it is a very complicated design. I think with this basic information is sufficient as the engineering student, since it is not given in our syllabus. So chain drives, only this information is sufficient. Thank you.